I first heard about the right side of the brain and the left side of the brain when I took psychology in college. One thing we learned was that the right side of the brain heightens the ability to be creative, while the left side is in charge of organizing and analyzing. Two very different functions. Sort of like being right or left-handed. If you use both hands equally, you're ambidextrous. What about someone who's able to use both sides of the brain equally? Well, that has a name too. It's called golden brain. Now, most of us tend to lean in one direction or the other, but there are people who are able to be creative and free-spirited and rigid and logical all at once. Examples you'll recognize include Leonardo da Vinci, a self-taught engineer who was also a painter, a sculptor, and a lot of other things. Michelangelo was a real underachiever. He painted the Sistine Chapel and was also an architect. Alexander Calder studied mechanical engineering before creating beautiful sculptures suspended in the air. It sounds exhausting using every part of your brain all the time. But when it works, an amazing experience is created. Welcome to Art Bytes, a podcast from the Nelson-Atkins Museum of Art, where we take you beyond just the art on the walls and into the stories of the artist and the ideas behind them. I'm your host, Kathleen Layton. Today I'm joined by artist Elias Crespin, who was trained as an engineer and actually worked successfully in that field for years before completely changing lanes to become an artist. Elias makes massive, magical sculptures that move and dance to a rhythm he creates on a computer program. His work perfectly integrates the universes of science and art. He grew up in Caracas, and his sculptures have been shown internationally and entered the collections of institutions including the Louvre, the Museum of Fine Arts Houston, El Museo del Barrio in New York, and the Nelson-Atkins. Since 2008, he has lived and worked in Paris. Thanks for joining us, Elias.
Thank you, Kathleen.
Let's go back to the beginning. Now, your grandparents were artists. Your parents were both mathematicians. What kind of a household was that to grow up in? I mean, did you solve math problems at dinner?
Well,
what was that like?
Sometimes. I remember my dad on the phone talking to a colleague and solving or working out a theorem together on the phone. So that was a conversation at home that I could listen to. I think that growing up in a household with encouragement for science and art through my parents and grandparents, that nourished me and gave me a reference of that being a natural and connected world. So I naturally saw it together. I don't really see the difference.
And what kinds of things did you enjoy doing as a child?
Well, building things, or reading as well, drawing. So both building and drawing. I wasn't that good at drawing, but I did very nice drawings.
I'm sure you did. What about the engineering? Now, you did go to school to become an engineer. Did your parents encourage that?
Well, indirectly, yes. I wanted to be an architect, in fact. Maybe because my grandmother, her background is in architecture, and I had friends' parents were architects, so I was very interested. But one day my father brought a computer home, the good old Apple II. I don't know if you're young enough to remember it. And it came with a programming guide, and I did the whole programming guide, and I learned. It was my first coding experience. I learned to code with that. And you would code lots of pixels, color pixels, and moving pixels. You would learn how to make pixels move. There were big pixels at the time. Mm-hmm. And I got fascinated by generating numbers and using those numbers to plot dots or lines on the screen. So they were the first steps of computer graphics. And that was really seducing for me. And I decided I'm going to study computer science.
And you became very involved in that. I mean, it kind of sucked you in, right?
Yes. And then you start working as a computer guy, a coder or a software developer, software engineer. And you do work for companies, for payrolls and ledgers. And it's not the same thing as plotting dots on the screen, which is what first seduced me. So I made a living out of it, but I wasn't so satisfied with it.
It had lost its shine.
Yeah.
Do you remember the moment when you first started veering toward art? Was there a moment that you just thought to yourself, I don't want to do these payroll ledgers anymore. I don't want to code anymore. I want to do this art.
I could live out of this, so I wasn't that unsatisfied. But I did have a void. Something was missing. And I remember stopping in front of a Jesus Soto cube, a nylon cube of Jesus Soto, and being so surprised and excited about seeing this work and thinking, wow, this computer functions or these mathematical functions modeled on a computer could control the movement of this cube, and maybe it would be a great thing. So I didn't think of it as getting into art, but I had this idea as an interesting, appealing thing to develop. And that stayed there for 2 years. And after 2 years, I did have the time to experiment the basic techniques behind moving something from a computer program. It was in the early steps of robotics. 20 years ago, we didn't have so much information or materials available as we have today. But there were some old disk drive motors and old desktop computers. I used those, and I did my first experiments with them.
And this took 2 years. Your first art project, you researched and you tried different things and you experimented and you stuck with it for 2 years. So you are a problem solver, an analytical problem solver.
Yeah, I had this, I do have this analytical way of approaching problems. Decompose a big problem into smaller problems and solve them one at a time with patience. Patience is very important.
Do most artists have patience?
I don't know. I sometimes don't have patience. But, for example, I'm leaving home and I can't find my keys. I start to get a bit anxious. But when you approach a project, if you can afford not to have a deadline, it's a complex project, and you set up a roadmap. Even though the farther parts of the road are blurry, are still blurry, you can start with at least a first part of the roadmap and go step by step, enjoying the way.
And that's probably
the
key, when you're enjoying the way. Mm-hmm. So problem solving is the same for engineers as for artists, really.
There is a similarity in the way you approach a problem, either an artistic problem or expression. How do I? Because in my art and in many artists' art, there is fabrication, materialization of the idea that requires an effort and a systematic approach. which engineering gives you. So I think having done this engineering first part gave me the tools to be the artist I am right now.
So let's talk about Grand Hexanet. It was first shown in Paris. It's now a permanent installation at the Nelson-Atkins. It's a geometric sculpture that's made up of metal rods that are all suspended in the air by invisible threads. Tell us where the idea came from and how it became Grand Hexanet.
Well, I had already produced two small hexanets. They are like about 2.5 by 2.5 feet. So they're not that big. Mm-hmm. Grand Hexanet is 20 by 20 feet.
20 feet by 20 feet. Mm-hmm. It's huge.
About, mm-hmm. Yes. It's not square. The dimensions are not square, but around 20 by 20. And the opportunity to make and the trigger to make this Grand Hexanet came when I was invited to participate in Artists and Robots exhibition in Paris that was held in the venue Grand Palais. And it was an exhibition on computer imagination, if so to say. Very interesting exhibition.
Which is your lane, computer imagination.
Yeah. So Jérôme Notre, the curator, together with Laurence Bertrand d'Orléac, co-curator, they invited me to imagine a work for a huge tower that stands above the honor stairway of the Grand Palais. There was only one possible hanging point, and it had about 35 to 40 feet diameter, the tower. So I imagined Grand Hexanet, and that's why it has only one suspension point. The whole structure is suspended on one point. And it was because I couldn't attach to walls or the rest of the ceiling. I could only hang where the chandelier used to be in that tower.
So interesting, because you're solving a problem like that, and the public never sees the problems that are being solved along the way, but you as an artist see them, and you have to be really meticulous with what you're doing.
Yes, there are lots of details in one of my works, but I like to hide all those details and present a simple to experience art. And yeah, of course you have the intuition when you see it that there's a lot going on behind the scenes, but I don't show it because it distracts. We can talk about it. We could go through the details if you want, but it's not the real art expression that I want to show. That's the means to get to the art, which is the dance of suspended physical elements.
And talk about that. When people come, when it was being installed, people could not look away. They stopped, they looked up, they couldn't believe these small rods, red metal rods, were moving, and they were fascinated by that. So what is it that you want people to take away from one of your sculptures?
Well, my best reward is that people get inspired and are brought some joy by experiencing the artwork.
How do you decide how the pieces will move? Each one of those rods has its own motor, is that correct?
In fact, each rod or tube, they are very light aluminum tubes, anodized red. Each one is suspended to 2 motors, one on each end. And
that's incredibly complex.
Yeah, so there are 90 tubes suspended by their 2 ends, each end to a motor. So there are 180 motors controlling the individual positioning of each end of each tube. And it's all controlled from a computer, and the computer is able to receive my choreography, the software on the computer that I wrote as well, receives the choreography definition and is able to convert that choreography into commands to the motors, so the choreography materializes in front of your eyes.
It seems like magic when you're looking at it. Is that what you intend?
I don't intend it, really, but magic is everywhere in life. So it is there too.
Where do you see your practice headed in the future?
I don't know. We'll see. But on this path that we're seeing, I have enough still to try. I want to try new materials like wool threads. I'm working with wool threads, and it's interesting. It's a very earthy material. I like it.
So it's on a wall, it's not suspended?
It is suspended, but I'm combining the wall with the metal rods or elements. So if you look at my website, you'll see an example called The Dance of the Catenaries, La Danza de las Catenarias, which is a work, the first work I've done with tubes and wool threads.
And your website, tell us what that is.
It's Elias Crespin or EliasCrespin.com or .net.
So a perfectly functional tech product is not so very different from a beautiful piece of art. Would you say that?
Technically, it's not very different, but there's a important conceptual difference in the intention of the outcome, which is just to look at it and for the joy of the expression. It's made just because of the joy of the expression of the artist. There's not a commercial or useful, particularly useful, practical intention behind it. So that's the main difference. And well, unless it's conceptual art, you won't have a wash machine in a museum.
Although there are a lot of moving parts there as well.
Yeah. It's interesting. Once I heard a person, she didn't know I was listening, and she saw my work and she said, "It's like watching the laundry on the wash machine."
Meaning you can't look away.
Right, and that you disconnect from your day-to-day just by watching it, like watching fire or the clouds or the stars.
Which was high praise that she gave you.
Yeah.
Well, I am very grateful to the golden brains like you who put such unexpected pleasure into the world. Thank you so much, Elias Crespin, for bringing your magic to us. You've been listening to Art Bytes, a podcast from the Nelson-Atkins Museum of Art. I'm Kathleen Layton. We'll see you next time.
Thank you very much.